Hi everyone, this is EasyPeps and welcome to this video tutorial, which is about creating a Voxelize effect from an input geometry, like I did in this scene, which is a voxel version of a Hanamura map from Overwatch. Now, this scene is obviously made from different geometries, but the principle is the same. They all, every geometry end up in the same HDA, which creates this Voxelize effect. So let's start with something simple like a sphere, and we will use a node called point from volume, which basically it generates as a set of points based on a regular grid given a closed volume, and you can increase the amount of point with this point separation parameter. So let's copy a box to make a voxel on this set of points. Let's add a transform after the box to link the point separation to the uniform scale of the transform. And now if you change the point separation, it will match to the voxel size. So we have our voxels, but we have a lot of points inside of the mesh that are useless and just heavy to calculate, so we will delete those points now. Let's create a pick node coming from the input mesh, which basically offset mesh based on its normals. And we will use it to create a group. So create a group node with the points coming from the generated points, and with the pick as second input. Let's set the group to points, call it like delete, disable base group, and enable keeping bounding region with bounding object, and copy the point separation to the pick distance in negative. So the group is basically selecting all the points except the outer set, and so we can delete the group with a delete node, set it to points, and set it to the previously created group. You can see that from 33,000 points we are down to 5,000. So let's switch in the copy to points. And also pack and instance this because it's much lighter to work, and we can use it later with the Redshift to render as instance from the SOP level packet geometry. Now let's create a color for our voxel, and let's say we want to create a random color value based on a ramp. So let's create a point wrangle, call it like CD random, and let's create a float value called call using a random with the ptnum. So now we are getting a float value from 0 to 1 randomized by the point number, and let's write it into the CD using a ramp with the color value. So let's click to connect spare inputs and go into edit parameter interface to change the ramp type from float value to color. And we can add a float parameter to change the seed of it, maybe. Now, a quick note about points from volume. It does not work if you don't have a close geometry. Like, for example, if you have something like this, points from volume will not work. You need to add something like a polyfill right before the point generation to close the surface. Now, this setup already works as it is, but it's fine if you can decide the color after the point generation, because if we create a color coming from the sphere, Let's set it to run from attribute and choose the position. So we have some color value. Let's disable the color randomization and display the copy to points. If you see, we don't have color information anymore. That's because point from volume does not carry color information, so we need to do something else to fix it. So let's start by creating some control for this setup. So let's create a node and call it control. And as parameter, we want for sure the voxel size. So create it. So size, let's say from 0.01 to 1. And copy parameter and best relative reference on point separation, and also to the transform node on the uniform scale. So now we can control it from here. So now create a switch node. So we can have the color randomization if you want to set a different color, or another point wrangle that will keep the color, the point color coming from the source geometry. So let's plug the delete into the point wrangle and put it as second input into the switch, and connect the switch to the copy to points. Now go into the parameter interface of control and create a toggle. Call it like OCD for override CD. And copy parameter and best relative reference to the switch node. Let's try to set the color to something like black to check if it's working. Yeah, it's working. Now, to keep the color from the source geometry, we need to access the point color value of this surface. So let's plug this node into the second input of the point wrangle. Let's call it like keep CD. And we will use the function called near point. We need to store it into a integer variable, and the function is near point with the surface geometry number as first argument, which is the second input because it starts from 0, so it's 0 and 1, so it's 1, and we will take the position as the second argument. So I created a point attribute just to visualize this. You don't need to do it. We will delete it as soon as we're done with the wrangle. So basically for every point of the point from volume, we're finding the nearest point coming from the second geometry, which is this one. And now we can access to the color of that point by storing into the vector variable and using the point function from the second surface input. This is the attribute for the NPT point number. And now we can update the color with the OCD variable. And as you can see, the color has been transferred to the voxels. Now let's test it with another geometry. Let's create a rubber toy test geometry and plug it into the color and into the peak. Try to change the voxel size, and as you can see, it's working. And if you have something with a texture instead of a point color, we can use something like attribute from maps. And we need the texture. So I needed to watch a tutorial to discover how to get this texture in a file, because I wasn't able to find it. I will point this video into the video description so you can save this image. And basically you disable the shader from the geometry and you select the texture in the attribute from map texture map parameter. So now with the export attribute already set as CD, if we create an add node and choose to delete geometry but keep the points, we'll see that the color has been transferred from the texture to the points. Of course, this mesh has already a good amount of points to transfer the color information, but if you have an uneven mesh, you probably will need to remesh it before the whole procedure. And this is just to visualize this, but we need the surface, so delete the head. And instead you will plug the attribute from map directly into the second input of the keep CD point variable. So now the color we are feeding into the point is the one coming from the map and not from the ramp we created previously. So by going into the copy to point, you can see that the color of our voxel has been updated according to the map. Now you will have a soft-defined color or a texture, so you will switch between these two. And also we have the control to override the CD with the random one. Now to render this out, let's use the attribute from map one. So this one. And go into the material context and create a Redshift material builder. And create a point attribute Redshift node, which is already set up as CD, and plug it into the diffuse color. Now I don't know if it's something to do with the current version of Redshift or Houdini that I'm using, but in order to this node to work, we need to assign the material to geometry level from here. If you assign the material inside the geometry with this material node, it will not show the point color. So assigning it from geometry level, it will make it work. And we have the copy to point with packed instance activated. So let's create a floor. Let's raise our geometry a little bit to make it go above the floor. Create a camera. Let's make it 1000 by 1000. And create a Redshift dome light to create some light. Let's pick an HDRI of this. And I will save this because Redshift tends to crash a little too much lately. And let's create also a material for our floor. So let's duplicate this one, delete the point color attribute, turn off the reflection, also for the voxel one, and assign the material to the floor. Now you need to remember to use the packed instance in an efficient way. You need to set the geometry level on Redshift OBJ and instancing tab. This one to instance Houdini compatible object, and also turn on instance SOP level packed primitives. In this way we are actually using this feature of copy to points. So let's try to render this out. Okay, as you see, it's working. And I believe we have to define some normals for the geometry. So let's create it after the transfer. Yeah. So that's it for this video, and of course you can add more parameters like I did in this version here, which I put into an HDA digital asset, so you can choose between different set of color, which you can define with the same ramp we did it. So all you need to do is to switch the source geometry. Let's try with the spigot. We need to do the same procedure we did before to extract the texture image, which is this one. It will give you an error, but it will write the image. So if you create an attribute from map, you will see the texture in the folder where you saved it. I saved it on the desktop. Yeah, there it is. Now we can remove the shader and plug it into the HDA, and it's working with all the parameters. So that's it for this video. I hope you find it useful. If you did, maybe consider to like the video and subscribe, and I hope to see you in the next one.